So it wants us to like graph those two lines, right? And that's it. So one of them's already written in a useful form for this, right? You can see how this one here, we'll do this one in red. Are you like colorblind at all? No?
No, not
okay. So sometimes this happens where kids are colorblind and I'm doing like, they can't even see it coming up. It's like I'm drawing stuff and they can't even see it. Okay, so the red one is in a useful form right now, right? So you can see how like the red one kind of looks like this equation up here.
Yeah.
Right? And y equals mx plus b. So you should have seen this before, right? So like, I'll do all the work in for like the red line in red, obviously. Okay, right. So you're looking for two things. Y and X, if you remember, like those are your, remember we talked about like inputs, we input things and then we get outputs out.
Which is the input is X and outputs Y?
Inputs X, outputs Y, yeah. So those don't change, right? So those are just like, they could be anything. So the two things that we need to know, what's a useful color? The two things we need to know is, oh, not that, this, M and B. Okay. M is like, from what I could gather last week, we were kind of okay with M. Okay, M's like the slope, which would be rise over run. Okay.
All right.
So if I were to take, all you got to do is get it in this form, y equals mx plus b. Okay, and then from there, you just read off the position. Like you go find the number in front of x, and that's your slope. Right? You remember talking about like the word per?
Mm-hmm.
That's the slope, right? So if I were to go to the red equation here, I'd see that the number in front of x is 3.
Yeah.
Right? So that's m. Because it follows this form. Can you see, like, if I were to rewrite the general equation underneath both of these.
And then so it's the 3 is the M and then the 4 is the B.
Yeah.
Yeah.
Okay.
Okay, I remember this, yeah. I just forget how to graph it.
Okay. So this piece here. So if you see a number, remember last week, am I allowed to do this?
Yes.
What happens if I divide by 1?
It's 0.
It just stays. Does this
or
zero?
No, it's not 0.
It just stays the same, right? Yeah. If you were to type that in your calculator, it would just stay the same.
Yeah.
So you're perfectly okay to do that. So with that, the rise over run, which was the slope, right, is just 3 over 1.
So you go up 3 and then over 1.
Up 3 over 1. Okay. Up 3 over 1. But now my issue is like, where do I start? Do I start down here or do I start here and then start? You know what I'm saying?
Yeah.
I don't know where I'm starting. So that's where B comes into play. B is what happens. Well, okay, so we'll do this two ways. The first way, your B value, this is the easiest way to you just read it off the equation and then you go find it on the y-axis. That's where you start.
And in this case, is there a different way you can get to that? Or is it just that's it?
That's just like in your head, you just look at the equation. Once it's written in the black form here, right? Once it's written in that way, you just go find B and then it goes on the graph right there. Now, the reasoning behind that now, and I think you have a little bit of like understanding from last week, and this would be the way that I would want people to actually understand it. Okay, so you got like B is 4 for this, and M is 3 over 1. Okay, those are your two like pieces of information. Okay, now you remember, because we just talked about this, input versus output. Okay, so you could plug in any value of x. So remember, x is along here and y is here. You could plug any value of x along here and it would tell you what the y is anywhere, right? But we saw last week that was like really, really slow. You don't want to do it that way. You don't want to have to like plug in 10 points to produce a line like this.
Yeah.
That's silly, right? You don't want to do it that way. Okay. So what you want to do, and this is the reasoning for this. Okay, so like I said, you can plug in any value of x and get the y value. What is the x value right here? Left to right, what's my value left and right?
I'd be 0.
0. What happens if I plug in x equals 0 into the red equation? What number do I get?
You can get 0. If you got, which equation are you plugging
The red
into?
one. The red one. So 3 times 0 plus 4.
That'd be 4. So then that's what your y is.
That's why it is what it is, right? When I plug in the value of x equals 0, I get my starting point.
Okay, I see. Yeah, I see how you did.
Okay. Now, that is always going to be the case. Okay. Which is why, like if I were to, you could just look at the red equation and plug in 0. It's going to wash itself out. Y equals 4. You go plug it right there. Okay. So now, now you know what your starting point is. You can actually plot this line using your slope.
So then up 3 over 1. So.
Up 3 to the right 1. So it's important. So here's the other catch. I'm going to say both these are positive. Okay. Up 3, right 1.
Yeah.
So up 3, right 1.
If it was negative, it'd be down 3.
Down or left. Down or left. Depends, right?
Yeah.
So you're going to figure out, we'll do that in a sec because we need to do the other side in a sec here. Okay. We'll do one more. So I'm going to go up 3 again, right 1. Okay. Okay, so this question is just asking you to graph the two lines. Nothing too crazy. Hasn't asked you to interpret anything. I'm kind of like mixing what we did last week up a little bit with what we're doing now because I realized we didn't really do this. But this is just one method to do this. This isn't the best way to do it, right? Yeah, you got the idea. Now, if I wanted to go in the opposite direction, I wouldn't be able to go like this, right? Because then it wouldn't be a line. I wouldn't be able to go down 3, 1, 2, 3, and right 1 anymore, right? Because now look at my line. It's not a line
all
anymore.
cockeyed, yeah.
Right? So that doesn't make any sense. So the opposite of going down 3, or sorry, the opposite of going up 3, right 1 is for you to go down 3, left 1.
Because that's what the opposite
It's
of
the opposite. Okay, and then you do it again. Down 3, left 1. Now you plot the point. Now you could, like, that's good now. We can like plot that. Okay. There's your red line. If you do these things in different colors, then it's clear to everybody, especially the person marking it, which line is which. Right? If you didn't do this in different colors, then I would say that you would have to label this y equals 3x plus 4. Okay, and label it, make sure it's clear which one's which, right?
Then they'd know, like the teacher would know what the rise and run is, so they know what they're looking at.
So then you could see like everything's all like segregated and organized, right? For the reasoning of if this was a word problem, like last week, remember we did the
we did a few of
the
those,
cars, right?
Yeah.
For that or the cell phone, which company's which line represents which company, you need to know that, right? So that we can actually make a decision.
Yeah.
So you okay with that?
Yeah.
Okay. So the blue equation is a little more complicated, but not crazy. Okay. The problem with the blue one, does it look like this form?
No.
Okay, so it's not useful that way. Okay. So what you're going to have to do is use the skills that we started with last week. You remember, like, solve for x or solve for y.
Yeah.
I want you to solve for y so that it looks like this. Okay? That seems like daunting, but all I'm asking you to do is get y by itself.
Oh, okay. So
right?
you go minus x on the left side and right side.
That's it. That's it. So now you're going to go y equals 4 minus x. Okay? This is okay if you know what you're doing, but it still doesn't quite look like this, right?
Yeah.
So you're allowed to reorder this stuff, okay, without doing anything. Okay, it doesn't matter where that is. So you could rewrite this y equals negative x plus 4.
Which that looks more like what's up
That's
there.
what we want, right? That's exactly it. So now you're able to say, okay, well, what's the slope? And what's the b value? Well, you know what the b value is, right?
Yeah.
The b value is on the end.
Which is 4.
4. So b for the blue equation is 4. So it's starting here, right? And then what's happening?
Well, it's negative, so it's gonna go down, but we don't know what the m is. That's the other thing. Or is it just 1 because it's
okay? So yeah, you're right. It's going down. That's fine. That's good. That's a start. But what did I say you were allowed to do?
But or you can do x over 1 or 1 over 1.
You can put 1 over, just like what I did up here with the 3 over 1.
Okay.
Right?
Oh yeah. Okay.
You're allowed to put anything over 1 because if you divide anything by 1, it's the same thing.
Yeah.
So this is just a way to visualize what's going on, right? So now your m value is -1 over 1.
Which is a -1 and then right 1.
Yeah.
Because that's a positive.
Yeah.
1.
Down 1, right 1. Down 1, right 1. Right? Does that make sense?
Yes. Then that's your one. Well, a little one. But
A little bit. So that's one direction, but you still got to figure out the other direction, right? You got to do the opposite of that in order to figure out the up in this.
Oh, yeah.
In this region, right?
Should be 1 over -1.
Yeah.
Right.
1 over up 1, left 1.
Which is just you just flip it pretty much.
Pretty much flip it, yeah. So you're gonna go up 1, left 1, up 1, left 1. Right?
Yeah.
There you go.
There's the line there.
Right? So now you got 2 lines on this graph. And they happen to, this wouldn't happen all the time, but they just happen to like cross each other here. This is your point of intersection, which we talked about last week a little bit.
Yeah.
Right? Where the 2 lines cross. So that's your decision point. This is just 2 random lines. Doesn't necessarily, it's not like the cell phone problem where that actually meant something. Right?
I'll write that down later.
Yeah.
Watch your,
Okay. So that's like, I wouldn't want, like on the purposes of a test, like there's 3 ways to do this. Where am I going to write this? I'll go all the way to the bottom. Okay, you could like copy this later or something. So when you're dealing with lines, there's 3 ways. Okay. The first way, and probably the slowest, and you don't want to do this, is to like use your input, output, like tables. Okay. So that would be like your X and Y's, and you'd plug things in to get outputs. You don't want to do that. That's slow. Like chances are, like for the purposes of the curriculum, you're gonna have to do that. Like some of my exam, like we had to ask the kids to do that. So you have to know how to do it, but it's really easy, right? All you're doing is taking in numbers, you're plugging them into an input to get an output out. And then you'd fill it in, whatever the numbers are. Does that make sense?
Yeah, and then after that, you're just solving the equation.
Yeah,
if there is one.
Yeah, if there is one. But you're like, from here, you'd like plot them on the graph to create a picture, right?
Yeah.
Not the most effective, or it's effective, not the most time efficient.
Yeah.
Right? Or efficient way in general. Okay. The second way is y equals mx plus b. Okay, so what we just finished doing with that, okay, where you find m and find b, and then use like your step pattern or whatever to graph it. Okay, that's the second way. A little bit quicker than this. Still not the most efficient to get your answer, right? That's what we're going to show you now. Okay, the third way, we're dealing with lines. Substitution. Okay, so we'll come back to that in a sec at the bottom portion of that page, but let's go up to the picture. A kind of funny picture. Okay, so this is like a visual prompt when we started like substitution. Okay, and like really, if you can grasp this is probably honestly harder than 2 lines, because what you got here is you have like there's 5 lines pretty much, right? using some funny pictures and stuff, right?
Yeah.
So your job here, and we'll see if we can work through this together. Okay, and I'll prompt you as we go. Your job is to figure out what each of the following shapes are worth numerically. You just got to untie it, right? So you're just looking at it and you go, okay, like how much is the tree worth? How much is the fire worth? Sort of thing.
The fire would be worth 9.
Okay. So your ability to do that off the top of your head is like, there's nothing more to this than that. Okay, that you like. People explain this point of intersection thing and this substitution. I don't know what happens, but kids like lose this ability to look at this and figure it out. Right? It's literally all that's going on. So you said fire was equal to 9. Why was fire equal to 9?
Because there's 3 of them, and there's 27. If you divide 27 by 3, then it's 9.
Okay, so if I were to write it as an equation,
Yeah.
3f equals 27, right? Would you agree with that?
Yeah.
So then I could solve for f by dividing both sides by 3.
And then you'd get 9.
Okay, good. There's one of them. Okay, your job now. You now know what fire is. So go find another like equation in here that you could solve for another shape based on what you just found.
There's 6 here because it's probably 3 times 2.
But how do you know it's 3 times 2?
Because if we put it in,
how do you know what a drink is, or how do you know what a tree is?
see, that's what I wouldn't know, but we could figure it out.
You could figure it out, but you'd hit a roadblock because you wouldn't know which one's which. So then you'd be like, okay, well let's see if we can look at a different equation then. Okay, is there a way for you to figure out what a tree is based on the fact that a fire is 9?
Other than here, I don't see any other. Oh, this minus a fire equals a fire.
Why did you choose that?
Because it equals a fire.
Because you have 3 things and you know 2 of them.
Yeah.
So you could find the third.
So
right?
If we do, so if that's, I need to.
You could label it like tree F and F, right? So you could go. I just want you to write an equation that says T for tree minus fire is equal to fire.
So if we know fire, so that's 9.
Okay, plug it in.
So
plug in what you know. So T minus 9 is equal to 9. Solve for T.
Wow, my mental math is slow. It'd be 9 because if you want 8 or 18. No.
18.
Yeah, 18.
Because you're gonna move the negative 9 over. It's gonna become positive, right?
Yeah.
Or add 9 to both sides. Okay, that's good, right? Now you know 2. That's like you're starting to unlock the pieces now.
So I can figure this out now. No, I can't. Yes, I can.
Yeah. Yes, you can.
How does that equal 6?
Just all you got to do is just like create them equations, right? So like drink times tree is equal to 6.
6.
Fill in the number. What's a tree worth?
D times 18 equals 6. This is where I'm like, because I don't know what times 18 can get 6. Because
so all you're trying to do is get D by. All you want to know is what's one drink
what's
worth.
D by itself? So we got to move 18 over.
How do you do that?
Uh,
Is it adding or subtracting? It's multiplying, right?
It's subtracting because it.
What's the opposite of multiplying?
Dividing.
Dividing.
But would you divide it by?
Divide both sides by
18.
Yeah.
So that's 18. Oh. And 6 divided by 18.
Yeah. You can reduce that. So if you divided both of them by, like, if you wanted to, divide the top by 3, divide the bottom. Actually, sorry, you could go bigger. So the way you reduce, have you ever been shown how to reduce fractions?
I have before.
Okay.
Not really
So like,
remember.
you can type this in your calculator, and like obviously it would work every time. Sometimes actually it would just give you a decimal, so that's not useful.
You
right?
could use the lowest common multiple between the two because it's still the same.
Lowest common multiple.
Like
How about the highest common multiple?
The highest? Oh, I guess. Yeah.
Or sorry, highest multiple, or like whatever would go into both. The biggest number that would go into both would be my way of doing it. So if I were to look at that, 6 goes into 6, and 6 also goes into 18. Right? So if I divided both these by 6, what would you get?
3.
3 on the bottom, but what about the
And
top?
then you just get 1 on the top. So
it's
1 over
1/3.
3.
So you find the biggest number. In this case, you got lucky with 6 goes into 18. If it was 3 over 18, you might get 3 would go in as well. So you'd have like divide both of them by 3, you'd get 1/6. Right? Does that make sense?
Yeah. I remember that, yeah.
Okay. So that's just reducing, right? So there's one, reducing 1/3.
Yeah, 1/3.
Okay, so that's what D is equal to. Okay, so you know the fire, you know the tree, and you know the drink. So we got to figure out one more, the umbrella.
Drink of 1/3. So
Okay, and then you can also, just for this, you can check off the ones that you've used now.
Okay.
Right, I've used that one, and that one.
And that one. So we got 2 left we need to figure out, and we're trying to find the umbrella.
Yeah.
We need to use this one because we don't know.
Yeah, we don't know
what those 3 are, and there's nothing on this side to tell you what it's equal to.
Good. So that'll be the final thing. Is like, what's the question mark equal? At the very end.
Yeah.
Right? But we need one. We need the umbrella in order to figure that out. So you see the thought process. How we're like, what you would have done there. It doesn't matter which one you start with. You're just gonna hit a different roadblock, and then you got to decide. Okay, what do I need to get over this roadblock? Then you go back to another equation. And if there's another one, then you go back. You're going to land in the same spot, right?
Yeah.
In order to do anything. You eventually would have landed on the 4th equation in order to figure out what the tree was, right?
Yeah.
I just gave you the fast track. Okay? But in your head, you're thinking right? Like, it doesn't matter which one you start with. You just got to, you're identifying, I didn't know what the drink was, so now I got to figure out what the drink was, right?
Got to kind of work through it.
You got to work backwards.
Yeah.
Right? This is what solving is, okay? So the last thing, so we're going to use the second equation here, right?
Yeah. So I'm going to put all I can see it.
Yeah, that's good.
And then, that's not 18. We don't know what that is yet.
The tree
That's
was
18, and then this is, what can you write that as?
the drink.
0.3?
No, I would leave it as a fraction. You'll see why. This is why we like fractions, right? Okay. So,
because we don't know what this is yet.
Yeah, we don't know what the umbrella is. Okay, so what we'll do, we need a little bit of space here. Okay. So, what you're going to do, we'll say fire, umbrella, tree, drink. You want umbrella by itself. How are you going to get umbrella by itself? So I wouldn't even put the numbers in yet. I would just be a little bit patient. Okay?
You'd have to. So I'm just gonna see these as on your thing. You'd have to divide everything by f.
Yeah.
Because you need to get u by itself.
Okay, so u is going to equal t times d divided by f. Now you can put your numbers in.
So.
And do the math.
We need u equals t times d over f. And then we should plug that in. What's t again? 18. How do we multiply a fraction? We could put that over 1 and then do it that way.
Yeah.
18
How did I?
over 3.
18. What is 18 over 3? That's
You
exactly
could
it.
divide it. It'd be 6. 6 over 9.
That's it. That's what the umbrella is equal to. That's it. That's like, put it over 1, and then you did top times top and bottom times bottom. That's it. That's how you multiply fractions, okay? Now, the last step here is to figure out what the question mark is. So just plug in your numbers. The umbrella is 6 over 9. We're going to multiply that by
18.
18.
No, is that 18? Yes, it is. And then this is 1 over 3.
Okay. Now
So
you could do this. The nice thing about multiplication is you can do it in whatever order you want.
you can do
Okay.
over 1.
Yeah, so the 18 over 1 again, right?
Yeah.
So now you're just multiplying all the tops and all the bottoms.
So 6 times 18. My phone's almost dead, but I'll see if I can.
How many, so if you were, like, this is how I remember, like, 9s and 18s, okay? 2 9s make 18, like golf, right? 2 9s make 18. How many holes do they play in 4 rounds?
5. No, not 5. Good God. Sorry, say that again. I got myself mixed up.
So, like, if you were to play 9 holes twice, it'd be 18. But, like, a typical, like, PGA Tour event is 4 rounds of 18, right?
Yeah.
So 72 holes.
Yeah.
Right? So that'd be 18 times 4. So now you got to add another 36 because it's 6. So 4 times 18 is 72.
Yeah.
And then add another 36 for another 2 18s.
I'm kind of confused for some reason.
Oh, yeah, you could just type it in. You could just type it in.
But I need to know like what's behind it though, so I can kind of grasp it a little better.
Okay.
So
all I'm doing is like the mental math around 18 times 6, which is 108.
108, which would be, well, I'm guessing would be 72 plus 36.
Yeah, that's what I was saying. Yeah.
Okay.
So that's 108, right? And then what's 3 times 9 on the bottom? That's what you got to do. 3 times
27.
27.
So 27.
So then you're doing 108 divided by 27.
4.
That's fine.
So we're always trying to get to this question mark. That was the end goal.
But we needed all the shapes
Yeah.
in order to do that.
And we had to figure that out.
All right?
Okay, so we use that and that. Bingo.
Okay, so I'll leave the other ones a little more tricky, and like I did get it earlier, but I got too fixated on what the shapes were. Not that one wants you to figure out what the question mark is, and that's it. Okay, so what I want to do now, like I don't want to do the same thing again. What I want to do is, if you turn the page over, I'm like gonna slowly ease you off of shapes and into variables. Okay, by that I mean, all I've done here is I've taken 2x plus 3y is equal to 7, and I have x plus y is equal to 3. Can you see what I did?
Oh, well, you just made the x.
I made them shapes.
Squared.
Yeah, I made them shapes. So I'm just going to ease you off, and then we'll go back to the 4th page, and we'll solve those 2 equations at the bottom using this method. Okay.
Okay.
What I want you to do is ignore the fact that these are here, okay? And I just want you to solve for the 2 shapes.
I don't even know where I'd start with this, just because.
Which one looks harder?
This one does, because there's
Okay, good.
more variables.
More variables. So I would say start with the easier of the 2. And all you want to do is get one of the shapes by itself, like what you did with the other one, so that you could figure out the other, like the first equation.
I'll get the triangle by itself.
Okay. So
I'll get the. No, I'll get the.
honestly, it doesn't matter.
Yeah.
So get the square by itself. So you're just gonna subtract the triangle from each side, right?
Yeah. So then I get square over here equals 3 minus triangle. And then
That's it. You're done.
that's it right there.
What are you gonna do with that? Where else do you see a square on the page?
Well, just in that line alone, there's only one. Or
Yeah, but you now know what it is. Like, let's say that was a fire. Fire is equal to 3 minus triangle. What are you going to do with that?
put it over 1? Or?
You could put it over 1, but what about... So basically the rule is, okay, so this one's a little bit less complicated than the last page because there's not 5 different equations. So once you solve for 1, once you use this one, or manipulate it in some way, the second one, like what you did, it's basically useless now, right? Until the end. So I would say, once you get the square, I see another square on the page. What's 1 square equal to?
That's where I got confused.
This.
Well, and so we just put in 2. It would be 2 bracket 3 minus triangle.
Yeah, close the bracket. Plus 3 triangles is equal to 7. Now, do you see any more squares?
No.
They're gone.
Yeah.
So now you're able to actually solve for what one triangle is. You just got to do some multiplication.
Which are... Oh, I forgot to put the 2 out here.
True. Yeah. Good. So, let me get caught up to you.
Gotta rewrite that. It's sloppy. I can't read it very well.
Okay. Now, that's the hard part done. Now all you got to do is like, you've got a 2. The 2 has to go to everything inside the brackets. You remember doing this?
Yes.
And it's attached with multiplication. So you're going to multiply everything inside the bracket. So you're going to go 6 minus 2 triangles. All right, see how I did that? 2 times 3. That was like, this is what I call like, we'll do more of this next week when we do like parabolas and stuff. I call this kind of like, it's distribution, but I call it like the rainbow. So it's like 2 times 3
is a 6.
Is 6. That's where the 6 comes from. And then 2 times the triangle is 2 triangles.
Okay. Okay, I get that, yeah. Minus 2
okay.
triangle.
And then you don't have anything to do with the 3 triangles because it's 3 times 1, so it's plus 3 triangles. And that's equal to 7. Right? Now, can you add numbers and triangles together?
No.
Or right, because they're not, it's like apples and bananas, right? You can only add the triangles with the triangles. Okay? So I would say, why don't you, this is what we call, at this stage, you should have heard this before, we're collecting like terms.
Yes, I remember doing that. So that would be 2 triangle.
Okay, so here's what's tricky, okay? So you're at, and you can think of this 2 ways. Remember what I said earlier, actually, you could do this. You don't even have to think about this in a hard way. You can rearrange these 2. What's to stop you from flipping the order of those 2? So I could rewrite this. What's 3 minus 2?
1.
1.
So that would be just 1, because then...
Yeah, it's 1 triangle. Okay?
Okay.
There's nothing wrong with that. And it turns out that it's the same. If you go negative 2 plus 3 is also 1. If you like, sometimes the reason why they show you the negative numbers is what are you going to do if you have like negative 6 plus 5. Now you're kind of stuck, right? You're going to have to deal with the negatives. But there's no saying you can't flip the order of these and go 5 minus 6.
That's 1.
5 minus 6. You'd be at negative 1.
Oh, negative 1.
Yeah, because you're going to shoot past 0, right?
Exactly, yeah.
Okay. So that's all.
Alrighty.
Okay, so
6.
So you're going to get 6 plus 1 triangle is equal to 7. How are you going to get triangle? Oh, there, I let you caught up.
I think that's how it was written.
Yeah.
Perfect. So 6 plus triangle equals 7. Well, triangle would equal 1 because if you take 7 minus 6, like if you flip that, try to get the triangle by itself because you could do it in that equation.
That's all we're doing.
7 minus 6.
That's all we're doing. Right? I want you to keep in track of what's this question asking us to do?
Find out what square and triangle.
Yeah. So we just found out what one of them was.
Which is 7. Or which is 1.
So triangle 7 minus 6. So triangle equals 1. Now, you have one of the shapes. How are you going to get the other one?
Just take 3 and do the same thing. Get square by itself and solve for square.
But yeah, don't we already have the square by itself?
We already have that.
So just plug in the triangle.
I'll finish this one. So we have equals 1 and then square equals 2. There. So triangle equals. Oh. So with these, do you always do a therefore statement? Because I know my one teacher, the one I had, she was really particular on having a therefore statement with anything. If you found two variables or something, then she was like,
you could say, this is what we're doing here. Is this is the point of intersection. Okay, it doesn't mean anything right now because I'm just giving you the mechanics. So this is purely mechanics. This is no context at all. You could say therefore a triangle is 1 and a square is 2. Like that doesn't mean anything, right? What it actually is this point of intersection. These are two lines, okay, and they meet at some point. So it'd be like this. It'd be like if I decided to I was graphing triangles versus squares, whatever they are, right? And this is like triangles would be down here and squares would be on this side, right? And like when I plot the two lines, I'd get something that looked like this, and this would be 1, 2.
Because that's where the line meets.
That's where the two lines meet. Okay, this is zero context because we haven't put any words on here. This is just purely for your ability to go through this process, okay? Now, I'm just going to remove the training wheels now. We're going to go back to number 4 at the top, and I want you to do the exact same thing, and you can, if you want to, you could color over. You could go I don't want to use X's. I want to use squares, and I want to use triangles. I don't care. Right? If it helps you, who cares? It's just a letter. The square is a box, and the Y is a triangle.
It's representing the missing numbers, basically.
The two numbers. Find the two numbers.
So we're using this top one now?
Both of them. You're going to use both of them, okay? But which one? Okay, yeah. So so remember what we did here. Which one did we start with? We started with the easier of the two.
Which is this one.
Good. So that's why you chose the top one?
Yeah.
Okay, because it's the easier of the two, right? So give me X by itself or give me Y by itself. I don't care which one it is. Doesn't matter.
Okay, we have that set up, and now we have to go to this one, which is set up not quite like that one, but
it's pretty close.
It's just the Y is kind of
you solve for X. Okay, so my decision is, and as you do more of these, it will make more and more sense. When you solve for X, you want to solve for the variable that lets you just plug it in and do the math. You don't want to do any more arranging, right? So because it says Y equals, you don't want to solve for Y, right? Because if we were to solve for Y, then you'd have two big pieces on left and right side, right? Does that make sense?
Yeah.
So if you just get X, now you can just take whatever X is equal to and plug it in for X, right? As opposed to if I solve for Y, now I got to put in what Y is, where Y is. So now I'm going to have 4 minus X is equal to 3X plus 4. It's a little bit more complicated, but why not do it
easy?
Put some thought into it and do it the easy way.
Yeah.
Right? Just requires a tiny bit of foresight as to what's going on. Okay. So you said we chose X plus Y is equal to 4. Okay. And then we solved for X, so Y equals to 4 minus X. Yeah?
Yeah.
That's what you got.
That's
okay.
Right.
You solved for X, sorry.
Yeah.
I solved for Y. I did exactly what I told you not to do. So X is equal to 4 minus Y. That's what you did.
Yeah, that's it.
Now, you have that. Go find the other equation. So the other equation is Y equals 3X plus 4, right?
Yeah.
You now know what X is. What did I do? I just replaced square with square.
Because right here it says X equals 4 minus Y, and then here's X, you just kind of plug it in.
Now do the math on that.
So, if we do everything in the brackets, it would be Y equals 12 minus 3Y plus 4. Is that right? So, then...
Deal with the numbers. You deal with the numbers first. What's 12 plus 4?
16.
Okay, so 16 minus 3Y. Now you're going to need to get 3Y by itself.
So we need to add it on this side and bring it over to this side, and then collect like terms on the left side. Yeah. Okay. So
you know what a lot of kids will do there? They'll say, "Oh, I want to divide by 3." You can't do that because then the 16 has to be divided by 3. Well, you do to one side, you have to do the other.
Well, now if you do it on this side, would you have to do it on the y as well?
Yeah, then you have to divide here too.
So it's just a lot more confusing.
It's not even like math. It doesn't even mathematically do anything for you. I don't think it just makes things way more complicated for no reason. A lot of kids want to they see that they want to get the y by itself, so they want to divide by 3. Don't do that.
So
okay. Do exactly what you just did.
Y plus 3y equals. Because it'll just add it on this side, but we'll just not add that in this next step. 16 plus 3y. Oh, I'm writing it completely wrong. I gotta do minus 3y plus 3y because then that cancels it out.
Yeah, good. So what do you get on the other side? Good.
Now you got 4y.
4y. 4y is equal to 16.
And this is where you can divide it.
Now, yes, good.
Y equals 4. So now if we plug it back into here. Oh, I'm looking at this one thinking it's okay.
You're doing exactly right. You just got to figure out what x is equal to now, right? So you know what, like you have it isolated already.
Yeah. So we know what y is. So if we plug it into here, x equals 4 minus y would be 4, which is 0.
Good.
So then x equals 0.
Okay, so what's your point of intersection?
0, 4.
Okay. Where is that on the graph?
0, 4. Holy, yeah, I guess that does make sense.
You see what I'm saying?
Yeah. I can see that.
So that'd be where you would write your therefore statement.
And then that's where it's like therefore.
Therefore, POI is 0, 4.
Why did I write therefore?
You could use the 3 dots.
I did, and then I wrote therefore again.
That's like it seems like a lot of work, but like if you do 10 of these questions, it's just like you solve for one, plug it in the other, bang, bang, done. As opposed to, why do you want to sit here with a calculator and do a table, produce a line? That's just one. Now you got to do the second one to figure out this.
This is so much more time efficient because especially on an exam, they give you a lot of the amount of time. You don't have tons of time to be doing graphs and tables and all that. You can just do this, plug it in, and right here you got it. So
you're interested that's the point of, you could even call it the point of interest, point of intersection, POI, because that's what you're going to make decisions about, right? So why don't you practice one, and then we'll do. You have the exam still. There's a question in the exam too. Okay. That we'll do after, but let's do a couple more of these because there are ways to trick you too. Okay, so let's go into, let's do number 1 here.
okay, so
and then we'll do like number 1 and then maybe number 4, and you can do 2 and 3 by yourself.
Now, could I look back on this
just
for the
keep
form? Because once I get it, it'll be there.
You just got to do 4 or 5 of them, and I bet you it's just like the same thing over and over again.
So solve for x and y, squares, and triangles, which is what these were. So it's kind of the same.
It's the exact same thing. That's all I'm asking you for.
So we just want the shorter one first, so we'll rewrite that. I like solving for x. I don't know why.
That's fine. You're going to find that it doesn't matter for this question. They're both going to be equally complicated.
Now, could I just, because I know it's going to be 5 minus y.
Yeah, just do that. And then scratch it out. So x equals 5 minus y. Now what are you going to do with that?
You have to leave it for now. And you got to solve for this right here. So, if we go back to that, see if I can get this. Because it's the same setup as this, we got to follow the same thing.
Yeah.
Which a triangle would be y. So it'd be. I'm just gonna rewrite this down here. 14. So. Oh, that's what I'm doing wrong. Okay.
So that doesn't change ever. Like what you're doing right there, it's the exact same thing every single time. Oh, careful though. Don't do 5 minus y.
Oh, because it's not y. It's
not,
4y.
It's not a triangle, right? It's a square.
So that's just 4y. Without
yeah.
There's no. We don't know what y is.
No. So now you're good. Now do the math on that.
I see. That's where I make silly mistakes, and then that's where I lose my points mostly.
Yeah. You can't just like if you were to look. This is why I did this here. What you did is you solved for a square, and then you decided to put the square in where the triangle was.
Yeah.
You can't do that.
Okay.
You know what I'm saying?
Yeah. So we got 10 minus y.
2. Careful. 2 has to go in everything.
And
so you did 2 times 10. 2y. Yeah.
Okay, that got me all. I'm just gonna redo this here.
Okay.
Start fresh. 14. Now we want these together, so we're gonna have to do 10 plus 2y plus 1y.
Where'd the 10? Oh, I see what you did. Never mind. You're okay.
All right, and then I'm gonna run out of room on this one.
You can scratch out 3. You can do 3 on the, or don't scratch it out, but you can do 3 on the back.
Okay.
There's nothing on the back of it.
So
just put a box around 3 or something.
And okay, so we got that line. Now we have just negative 2y. 4y equals 34.
Is it 34? What is it?
10 plus 14. If I'm completely wrong, it's 24.
24.
Oh man. Okay. Okay, so now we gotta solve for that. This is gonna be negative 2, because if you do negative 2 plus 4, negative 2y.
Yes.
Or you can
reverse it. That's fine. What's
4y minus 2y equals 24, which would be 2y.
Yeah.
2y, 4, divide that.
So y equals 2, put a box around that. What are you going to do now?
Now we got to solve for x. Which we just plug that in, so it would be x equals 5 minus 12. X equals... we can't reverse that because it's subtraction.
Okay, so that's an instance of where it doesn't make sense now, right? Because what you're gonna do is you're just gonna have to you're gonna have 5 minus 12. If you rearrange it, you're gonna have negative 12 plus 5. See how that's not helpful?
No, I just get
it's forcing you to make it's forcing you to know your negative, dealing with negatives.
Which I'm not very good at. Which 5 and then you do.
Okay, so the other thing
would be negative 7.
Yeah.
Okay, there you go. So x equals negative 7.
So that was your point of intersection.
And then I just write my therefore statement, and then
POI is
it would be x before y, so it would be negative 7,
12.
All right, so then we're on to 2.
Do number 4, and then we'll do.
4.
What do we got? 9 minutes. Okay, I think you got enough of it. Let's go to the exam, and let's do something that actually means something.
Oh crap! Okay. I see it.
Or it might be the exam. Do you have this question? You might not have this question actually, because I didn't give you an exam. Okay, I didn't give you this question, I don't think.
Yeah, no.
Okay, let's that's like the exam prep. Why don't you go on the back of a page? You don't have to copy this down, but you can watch it later. Like the questions here, you can free still it, right? You can hit pause on YouTube or something. So on the back of this, okay, so Staples offers teachers a membership of $20. Okay, so if I were to go to Staples, I could pay $20, and then charges $1 per box of pencils. Okay, so then this would be an example. I'd be like, okay, stop. Okay, there's information there. Okay, and then I'm like, okay, Grand & Toy, this is a different store, offers teachers a membership of $5, way cheaper, but charges $6 per box of pencil. Okay. So you want to create the equations for these two models, okay? Really, like the word problem is just giving you context around what the work we're doing, okay? You want to tell me or advise a teacher which company, Staples or Grand & Toy, they should go to.
Which more like cost efficient?
Yeah, depending on what?
The per?
Yeah, how many box of pencils they're going to need to buy, right? So we're doing the exact same thing, the work anyway. Then your final piece here is like, okay, you got to make up your mind. You got to advise them, right? So let's come up with the two equations. Let's say, we'll say dollars, because that's what we're going to spend, right? Actually, you know what? We just won't make this fancy. We'll say y equals, right? And then on the right side, we're dealing with the information. So how much does it cost me for a membership at Staples?
20. So would we write it like the slope? So 20x.
20. Careful. Where's the x go?
That'd be where the per is.
So where per.
You just write x because 1 equals x anyways. So
Staples. That's the equation. Okay.
I'll write this just the equation.
Yeah, that's okay. You could like make sense of it later with the word problem. Okay, you do the second word equation.
20 plus x. So we're gonna write it like the other ones too. So that would this be like an x?
We can do that after. Yeah. Why don't you just come up with the equation first? So just do the exact same thing. Y equals
5 plus 6x, which is gr or gt. Yeah, that's what I got.
Okay. So use substitution to solve for the point of intersection. This one's a little trickier.
Yeah, it is. Yes, yeah, I don't know. Like, where are we substituting because we already got the numbers?
You could do this one of two ways. Okay. Remember, you have a triangle is equal to something, and you have a triangle is equal to something. So why can't you take what this is, the triangle, and replace it where the triangle is? So
and then vice versa.
Or you could do this. Maybe you don't like it that way. Maybe you want to solve for x in this one and plug it into there. So you would do, okay, in the first one, I'm going to deal with the first one. And I like the first one because it looks a little easier than this one, right? So solve for x in the first one in Staples. So you're going to go y is equal to 20 plus x. I can subtract an x from both sides, can't I?
Yeah. So
could
you rewrite
actually, that doesn't even help you. You're going to have to do the way I said. Because now you got both variables on the left side, but it's not any good, right? Useless.
Yeah.
So let's spend our time trying to make sure that you're okay with this. Okay. It doesn't change. It just looks different than the last one. This is easier, actually. It just looks worse. Okay. You have, and maybe it'll make sense after I write it out. You have a triangle, and you have a triangle. Right? Both of them are equal to something. So why can't you take what they're equal to and put it where the other one is? Effectively turning it into this.
Which combines the two as well.
This is a triangle. That's equal to triangle.
So left should equal right as well.
Yeah.
So they should be the same in the end.
Yeah. So why don't you solve for the variable now?
Well, you could do what's that called? You can do like well, yeah, I don't think you can do it then, like the like terms, because it's on the other side of the equals.
But why can't you bring stuff over?
I guess you could.
Right? Why can't you go?
You could take 5 and move it over there, and x move it over there. So it'd be 7x, and then 25 equals 7x.
Is it 25? What is it?
Or no, that wouldn't be 25. That would be 15 equals 5x, which would be 3. I was adding both sides. That's what I was looking at. So x equals 3.
Okay, that's a little trickier, okay? And it's trickier to see it, but it's easier to do mechanically.
It's like, for me, it'd be hard if I looked at it and be like, oh, I got to move that here. That would be the step I would be missing.
Yeah.
So I'd be, yeah.
But you could see how, like, if I took the x and I moved it over. Oh, I suppose. Okay, let's try it another way. Okay, I think I just moved the wrong thing. Okay, so you could think of it that way, or you could do the way you were saying. Okay. Tradition, like, this took me a long time to see that, visually see that. Okay, what you could do is still do this. What's wrong with taking the 20 and moving it over to the other side? Forget that this is here for a second. Why can't you just get x by itself?
You could.
Okay, so why don't you just, that turns it into one of the other questions, right? Just get x by itself. So you could go y minus 20 is equal to x. Then plug it into there.
So then x6 it'd be 6 bracket y minus 20. And then you'd have to do 6y minus 120.
Yeah.
And then you have to, also it's on the, wow, could you switch those around a little bit to make it 5 minus 120? Or no? Because
you want to move, well, you're going to have to move this over too, right?
Oh yeah, you would, because then you'd have
to get the like terms.
You'd have to go minus 6y, y minus 6y.
Okay.
Equals 5 minus 120, which is, it's a negative number.
Negative. What you could do, negative 6y plus 1. What's wrong with that? 1y. Or there's a 1 in front of the y. So what's negative 6 plus 1?
It'd be 5. So negative 5y.
Good.
And that'd be negative 15 on that right side there. And then
what is it? Negative, it'd be
negative 15.
Negative 115.
115. And then you divide that and it ends up being positive.
I don't know what some of this is. Yeah, good. So it'd be whatever that would be.
I think if you do negative divided by negative, it's a positive.
Mm-hmm. There you're done.
Yeah.
Okay.
Does
that make sense?
Yes.
Oh, okay. Okay. Yeah, we just finishing.
Oh, okay, sure. Or I can just wait in the car. I don't want to.
So we're pretty much done, eh?
Yeah.
So you get this now, right? Did we saw you had x by itself, right?
Yeah.
You go y, so just take it and go. What y is equal to 23, right?
Yeah.
23 minus 20.
And that's 3 equal, which is over
Yeah, we found that already the other way. Right?
Yeah.
So then you're deciding, okay, if I were to graph this, along the x-axis is going to be like number of pencils. right? And along here is going to be the amount of money you're spending. Okay, so it doesn't matter what these two lines look like. They're going to do something like this, right? But the important part is that they cross here at 3 and 23. Okay, which means you're going to be spending $23 regardless, right? That's kind of the optimal amount.
Yeah.
And then both companies that's going to occur when they buy 3 boxes of pencils. Okay?
Yeah.
So when you buy 3 boxes of pencils from either of these guys, the price is the same. Okay? So if you buy 4, then one of them is going to be more expensive than the other, right? And you could figure it out from your equations. 5 plus, if I were to do this, 5 plus 6 times 4, that's going to be 29, right?
Yeah.
Well, what if I did it here? 20 plus 4.
24.
So then, at 4 boxes of pencils, Grandin Toy is more expensive, right?
Which is, yeah.
But Staples is cheaper at 4 boxes. So then that's how you would decide. You'd look at your 2 equations and you'd go, which one should I recommend? You know what I mean?
Yeah.
But the 320 is like the break-even point. That's where they're the same.
And then after that, it's kind of, you can tell which one you want.
Yeah, that gets back to, remember last week we looked across here and we decided which graph would we hit first.
The one that
Is it going to be this one or is it going to be this one? You know what I mean?
Yeah.
See how they flip? That's what we're getting.
Alrighty.
Make sense?
Yes.
Good.